This video demonstrates math functions in C++. The program we're going to write calculates the hypotenuse of a right triangle given two legs. So let's add that into our multi-line comment here, given the two sides. The other two sides, I suppose. There we go. Okay, so we need to get from the user the two sides, and let's make them integers. So from one side we need to get let's call it side, well actually call it side, yeah, let's call it side 1. And then we'll have another side which will be side 2. And then what we're going to do is create the hypotenuse. So we'll have hypotenuse. Now let's ask the user to enter side 1. And then we'll get side 1. And let's test that program. Compile and execute. Enter side 1, we'll say it is 5. Okay, that's fine. Let's make sure that it's actually outputting correctly, which would this will verify that the user input has been stored correctly. So whatever the user input, we should have reflected right back to us. So we put 5 and we get 5 reflected back to us. Okay, that's a good verification. The next thing we can do is enter side 2. We can just ask the user to enter side 2, and then we'll put the value into side 2. And once again, let's just verify that we got the correct value inputted from the user. Okay, so side 1 we'll say 5, side 2 we'll say 10. There we go. So the values are reflecting correctly for side 1 and side 2. So that now we can calculate the hypotenuse. I'm removing that additional test output, which we don't need anymore. Now let's calculate the hypotenuse. The hypotenuse is side 1 squared. So we can say pow, comma, 2. And let's see how that works. See if we can get this working. We know what we need to put though. We know that the hypotenuse, let's do a little bit of a pseudo code. So we know the hypotenuse needs to be side 1 squared plus side 2 squared. I'm using those carets to represent as if the 2 was actually a squared symbol. And then what we need to do is we need to get the square root of both of these. And that will be our hypotenuse. So the first thing we're testing is this side 1 squared, and we're going to do that using the function pow. It's the math function. And then we'll output the hypotenuse. And to make that output look nicer, we'll add an additional new line. Okay, let's try this out. Okay, we've got an error on line 20. Pow is not declared in the scope, which is correct. Okay, we forgot to add in the include for C math. Easy fix. Compile again. Ooh, we've got a nasty error here. Let's start from the top. So line 21, which is the line where we're using the function pow, a call of overloaded pow int, comma int is ambiguous. So it doesn't, the pow function isn't designed to take in an int, comma int. So 2 ints is what we have here. What if we make this into a double literal instead of an integer literal? It's a floating point literal now. Now let's try that and see if... not quite. Well, we're just getting a warning here. It's on line 21. And the warning is saying we're converting to an int, which is this hype, from a double, which is what pow is returning. So one solution is we could static cast to be an int instead of a double. So that's one solution. Let's take a look if that's actually going to work. Yes, it removes the warning. And let's see what the output is now. So if we enter side 1 is 5 and side 2 is 10, then the number 25 is output, which is what side 1 to the power of 2. So 5 squared, 25. Yeah, Okay, looks like we have a good understanding of how POW works. So what else do we need to do? We need to also add, so now I'm going to add this part here. So we need to add side 2. So I'm going to copy side 1 and make that into side 2. So we have side 1 squared plus side 2 squared, and that gives us this middle part here. Okay, let's compile and test to make sure we're doing well. Now I'm going to pick numbers that I know how to square really easily. So 5 and 10, I'm good at squaring those. So 5 squared is 25, 10 squared is 100. Add them together, 125. We're doing well. Okay, the final piece of the puzzle is to add the square root. So we can add a square root, which is just SQRT, and we're going to surround that around the two powers, which are these, the highlighted. So we need to add a parenthesis here, and you can see that parenthesis lines up with this parenthesis for square root, and then the last parenthesis lines up with the parenthesis for the typecast. Okay, let's compile and test. So we have 5 and 10, and the result is 11. So 125, the square root of 125 is a little bit over 11. 11 squared is 121. So 125, the square root of this is a little over 11. What if we try a different number here? Let's do 3, 4, and the result should be 5 as the hypotenuse. 3 squared plus 4 squared, that's 9 plus 16, which is 25, and then we take the square root of 25, and that's 5. So our equations work. We do lose a little bit of precision, however, as on this previous example where we had 11. How can we deal with that? Well, one thing we can do is change all of our data types from ints to being doubles. So let's just do a quick test, see what happens. And instead of doing this typecast, now we don't need to. We don't need to do this typecast, so I'm going to remove the typecasting. Now all of our inputs are doubles, and our output is also going to be a double. So let's recompile and test this program using 5 and 10, and here we have a result of that's much more accurate. The hypotenuse of a right triangle that has one side of 5 and a second side of 10, the hypotenuse is then 11.1803, which is more precise than just 11. Thank you.